well, let's just say plus da 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 plus h to the n. The larger point here is everything in here has h squared or higher power of h on it. And so when you calculate the difference quotient there, the only thing that survives is that initial n times x minus n1, x to the n minus 1 term. So this is written out in more detail in my notes on page 154. So, but there's actually a few other arguments I can give for the power rule, so I'm just going to leave that just like that. We can also prove the power rule using what's called the product rule, and once we learn the product rule, we don't have the product rule yet, right? So what are rules of differentiation, right? So one of the rules of differentiation, of course, is the power rule. You know, derivative of x to the n is x times n times x to the n minus 1 power. But there are other rules. And I'm not going to prove these today, but I'll just state them for you. If you have a constant times a function, you can pull the constant out. If we have the sum derivative of a sum of two functions, you can break it up in the sum of the derivatives like this. So those are the two rules of differentiation I'll probably cover Wednesday. All right. And so you have that to look forward to. Let's see here. And then the other thing that we need to, coming up soon, next time, I also need to explain to you why d dx of e to the x is equal to e to the x, it turns out. So the derivative of the exponential function is the exponential function again. And I was hoping to talk about this today, but I just, things went sideways here. It's okay, we'll get to it Wednesday. Derivative of sine is cosine of x, but and the derivative of cosine of x is actually minus sine of x. So these two things require a certain geometric analysis. So, which we don't quite have enough time for at the moment. I think, though, what we could do is look at the derivative of cosh. So just for a moment, suppose that we've already proved these things. They're not that hard to prove, actually. They're definitely easier than some of the homework you had this time, mission 3. Like, I don't know, I think these intermediate value theorem problems are kind of mysterious because it's about an existence theorem. It's a little bit off-putting. Check this out. So what if we want to differentiate the hyperbolic sine? And suppose for a second that we know we've already established these truths, right? What's the derivative of the hyperbolic sine? That's the derivative with respect to x of 1/2 e to the x. Oh, goodness, now I've got myself into trouble. We can't do that yet. You see the problem? Oh, goodness. I can't actually do this yet. Why can't I do this one yet? I could pull the half out, right? But then I'd be stuck because we don't have tools yet to differentiate something like e to the minus x, right? So pulling constants out, sum rule, and these are our basic tools in our toolbox. But it turns out we're going to need something called the quotient rule or the chain rule to do that one. So we'll have to come back to that later, actually. My bad. Sorry. Later. Well, I guess we'll stop here since I mean, I could prove those, but I think I don't want to hurry something, so I'm going to stop it here.